Welcome back to Tightwad Workshop. Today we're going to be converting this old pole-mounted fire hose reel into an A-frame unit so that I can pick it up and move it around the yard to wherever I need to use it. Now before we do anything else, we've got to uncoil this off the reel, so let's go ahead and do that now. This particular hose reel is 36 metres long, that's about 120 feet, so it should be long enough to reach almost to my letterbox from the backyard. You can find this kind of fire hose reel in car parks, shopping centres and office buildings. Here in Australia they have to pass regular inspections and they get replaced if they fail the test. I bought this one from my local tip shop a few years ago, and in this video we'll finally be getting it ready for use. We're going to need to disassemble it, so I'll start by removing these 5 bolts. Now the instruction plate and the end plate should lift right off. The water passes through this internal metal pipe, and this plastic piece has a rubber O-ring to allow for rotation while also preventing water leaks. Now we can remove the 5 matching bolts from the other end plate. We'll also need to remove this lock ring to take off the end plate. It's doubly locked in place with these 2 grub screws, which are usually made of metal that's about as robust as soft cheese. Much to my surprise, the first one unscrewed successfully, but the second one rounded off around the hex key in the usual manner. I've dealt with this kind of problem before though, so we'll use the vice grips for a more destructive removal method. The lock ring's still too tight to turn by hand, so we'll use this lock ring spanner to get it started. Sometimes you need to use a hammer like this to break the lock ring free. This one didn't need it, but I thought I'd show the technique anyway. Once we've removed the lock ring, we can take off this plastic spacer, then the end plate will lift right off. There's also another plastic spacer underneath the end plate. For our next step, we'll need a wrench with lots of leverage. This isn't strictly the right tool for the job, but it's the only one I have on hand that will fit over this nut. Once the nut's been removed, we can slide off the hose guide as well. I'll be connecting the hose reel to a water supply using a screwed-on nut tail, like these ones. These use a rubber washer to make a watertight seal. Both of these nut tails will fit onto the pipe's screw threads, but I'm going to use this steel elbow instead, partly to change the direction of the water inlet, and partly because it has a much wider sealing surface for the rubber washer. It turns out that the pipe was fitted into its socket with some kind of epoxy resin, as well as the screw threads. But after applying some heat to this area with a butane torch, I was able to break it loose. Unscrewing pipes like this is the correct use for this kind of pipe wrench. I'll be screwing this pipe nipple into the socket first, then attaching the elbow to the nipple. We'll wind some of this Teflon tape onto the threads first, just to make sure that we get a watertight seal. This Teflon tape works a lot better if you wind it onto the threads in the same direction that you'll be screwing them into the socket. I'm sorry about that bad camera angle, but I'm sure you get the idea. I'll just blow the debris out of the socket first. Now we can use our pipe wrench again to tighten it up. I'll wind some Teflon tape onto the other side of the nipple as well, then we can screw on the elbow. We want the elbow to end up pointing out in this direction. Now we can fix those dints in the end plates. This doesn't need to be a perfect job, I'll just flatten them out enough to work. Some of the dents will come out easier if we hammer from the other side. This rolled edge should straighten up okay if we hold the plate this way, then work it with the hammer. It's not perfect, but it's close enough for government work. I'll use the same technique to fix the dents in the other end plate. I'm always a bit suspicious of welding metal like this that I can't properly identify. So we'll be welding the frame parts to this mild steel plate, then welding the plate to the casting. That'll give us some extra options if the casting turns out to be unweldable. Now we can mark the middle of this piece of steel pipe and cut it in half with our angle grinder. If we're lucky, the cut will still line up when I get back around to the starting side. Just take your time with this, you don't need to force the disc down into the workpiece. Next, we need to find an angle for the legs that will give us a bit of clearance underneath the end plate. If we make this too low, then our hose reel will end up resting on the ground, and it won't be able to spin. That looks like it'll work, so now I'll mark and cut out some notches in the legs so that they'll fit against the centre plate. Now we can weld the legs onto the centre plate. The hose reel isn't super heavy, so these don't need to be full seam welds to support its weight. As usual, I'll chip off the slag and examine the welds to make sure I have a good attachment between the pieces. Next we'll need to mark a fish mouth cut on the ends of the legs. These usually look pretty ugly once I've cut them out, but so long as you get a reasonably close fit with their matching parts, they'll work okay. Now we can fit the legs onto the feet and tack weld them in place. I've only tacked this side of the welds so that I can check the alignment and bend things back into position if necessary. Now we can seam weld the feet onto the legs, being careful not to burn holes through our steel tubes. This isn't a structure that needs to hold against huge forces, so we don't need massive welds here. Once again, close enough for government work. Next, we'll attach the casting to the centre plate with a couple of clamps and see if we can weld it on. The weld looked wrong and sounded wrong, and it didn't stick together either, so we'll go to Plan B. Plan B is to make a pocket for the casting using this square rod. The pocket will surround the casting on three sides and carry its weight. Then we'll attach the two pieces together using bolts. I'd prefer to drill the bolt holes from the top, but we don't have enough clearance for the drill. So I'll measure extra carefully and drill the holes from the bottom instead. I got lucky with the bolt holes and didn't penetrate the water gallery on the casting. Once both of our bolts have been fitted, we can reassemble the reel on the spindle and coil the hose back onto it. Now we can attach a water supply to the reel and give it a test. It does have a small leak, but that's just because I didn't tighten that nut tail enough. Most of the time these hose reels will have the brass nozzle cut off for scrap, but this one was intact. It gives a strong water jet, but it doesn't have a fan or spray setting. If you need that capability, you'll need to replace the nozzle with something more suitable for your needs. That's all for now. Thanks for watching. Tightwad Workshop is filmed in front of a live studio audience.